Did you know the Earth's magnetic field might one day flip upside down? Imagine your compass pointing south instead of north. This phenomenon has happened hundreds of times throughout Earth's history. Scientists believe we might be on the brink of another magnetic reversal. Could this disrupt technology, endanger life, or even spell global chaos? The magnetic field is like an invisible shield that surrounds our planet, protecting us from harmful solar radiation and cosmic rays. Without it, life as we know it might not exist. But here's the kicker: this shield isn't static. It's constantly shifting, and every few 100,000 years, it completely flips, swapping the north and south magnetic poles. That means your compass would literally reverse directions. The last full reversal happened about 780,000 years ago, during the Stone Age. But scientists have found signs that Earth's magnetic field has been acting unusual. It's weakening, and the poles are drifting faster than ever before. Could this be the start of another flip? And if so, what happens next? Let's break it all down. Here's the problem: while magnetic pole reversals are natural, they're far from predictable. A reversal doesn't happen overnight, it can take thousands of years to complete. During this time, the magnetic field weakens significantly. This weakening could leave Earth more vulnerable to solar storms, intense bursts of energy from the sun that can wreak havoc on satellites, power grids, and communication systems. Now imagine a worst-case scenario. A massive solar storm hits during a reversal. Satellites fail, GPS systems go down, power grids collapse, and global communication grinds to a halt. In 1859, the Carrington event, the most powerful solar storm on record, caused telegraph systems to spark and catch fire. If a similar event happened today, the damage could be catastrophic. But there's more. A weakening magnetic field could also let in higher levels of cosmic radiation, which can damage DNA and increase cancer risks. And then there's the wildlife. Many animals, like birds and sea turtles, rely on Earth's magnetic field for navigation. A reversal could throw them completely off course, disrupting ecosystems worldwide. So, what exactly causes these magnetic flips? It all starts deep inside the Earth. The planet's core is made up of a solid inner core and a molten outer core, both composed mainly of iron and nickel. The movement of the molten iron creates electrical currents, which generate the magnetic field in a process known as the geodynamo. But this system isn't perfectly stable. Over time, the flow of molten iron can change, leading to a gradual weakening of the magnetic field. When these changes become significant enough, a reversal occurs. Scientists have identified at least 183 reversals in the last 83 million years, with the shortest gap being just a few thousand years, and the longest lasting over 30 million years. Interestingly, the current weakening of the magnetic field is happening faster than expected. The South Atlantic anomaly, a region where the magnetic field is unusually weak, has been expanding. Satellites passing through this area often experience technical issues, hinting at how a weakening field could affect our technology. But here's the twist: reversals don't always follow a predictable pattern. In some cases, the magnetic field starts to weaken and then recovers without flipping. These false starts, called excursions, add another layer of uncertainty. One such event, the Lachamp excursion, occurred about 41,000 years ago and lasted for around 1,000 years. During this time, the field weakened to just 5% of its current strength. What about the timeline? If we're headed for a reversal, when will it happen? Unfortunately, there's no clear answer. It could take thousands of years, or it might not happen at all in our lifetimes. Scientists are monitoring the field closely, but predicting the exact timing is incredibly difficult. Let's address the burning question: how bad could it really get? Well, the truth is, we don't fully know. While past reversals didn't cause mass extinctions or global catastrophes, the modern world is far more dependent on technology. A weakened magnetic field during a reversal could amplify the impacts of solar storms, potentially causing trillions of dollars in damage and plunging society into chaos. Take, for example, the 1989 solar storm that knocked out power to the entire province of Quebec in Canada, leaving millions in the dark. Now imagine that on a global scale. Power outages could last weeks or even months, disrupting everything from water supplies to healthcare systems. And then there's the long-term impact on climate. Some scientists believe that magnetic reversals might influence Earth's climate by altering the amount of solar radiation reaching the surface. While this is still a topic of debate, it's another reason why understanding reversals is so important. So, what have we learned? Earth's magnetic field is an incredible, dynamic force that has protected life for billions of years. But it's not permanent. Reversals are a natural part of the planet's history, and while they bring challenges, they're not the end of the world. The real challenge lies in how we prepare. By studying the magnetic field and its behavior, scientists can help us minimize the risks and adapt to whatever changes come our way. The next time you use a compass, remember that the magnetic north it points to isn't fixed. It's a reminder that our planet is constantly changing, even in ways we can't see. The question isn't if the magnetic poles will flip again, it's when.